So to remove the spindle from it and remove the bearings, there's a space in this. What you want is the bottom of the cartridge at that space so that the bearings have room to move out. So what you do is put it in, so the bottom is in that space. You don't want to push too hard. There's O-rings on here that are very sensitive. You don't want to abuse them. So
This is an electric cartridge head rebuilt.
So you use a tool that's broad enough that it's not going to interfere in any way with the insertion of burrs or whatnot, and you just gently tap till the spindle pokes through, and there is a flange around one of the bearings that usually is very stubborn to come out, and that is this center ring that goes over this bearing.
The back one or the
The
front
back
one?
one, yeah. And that's, you know, normally you could just poke it right out, but this is the thing that's stubborn. It always wants to stay in. So you have to put it in the vise and tap it. There's no way you can press it out, so because that ring will stay inside. So, there you go. And then
Removing the bearings of an electric cartridge.
these are more or less customized tools. You grind them and work them whichever way you need to have them do the job. So in this case, we're using it to, you put the bearing in and support it, and keep in mind inside here is a little flange, a little ridge. You don't want to have that catch on the tool or wherever you insert it. So you got to make sure the spacing is so it is only contacting the bearing here. So what you do is and you don't want to push directly on the button, so this little tool goes over top of the button to keep you from pressing on. If you push too hard on a vise, on a button, you often will destroy the chuck. So you got to be very careful about that. So what I do is I pull the tool back so I know it's only contacting the bearing. A little tap, voila. Moving the top bearing, you remove the bottom bearing. There's that ring. Keep that. That is good. Do not mistake this for an outer race of the bearing, which often the bearings will break and the part will be in here. Sometimes the bearing will break, this will separate, but you have to discern which one is a bearing cover and which one is the outer race, which is junk. There is a ridge inside where the balls roll around. This clearly has none, and it also has a flange on the back that butts up against the bearing, so this is our spacer. Take off that little tool. What I use is this, because the gears are a certain diameter. Again, just like putting the bearing in the tool, you cannot put any pressure on them. You're going to damage them. So what I do, now I don't know any other way to get this off other than pushing this through, which causes a distortion in this spacer. But what we have to do is push it out. Then we realign the spacer flat to what it to its original condition. So just a little tap. Again, you want a tool that's wide that isn't going to affect the spindle, and if it takes too much pressure, well, you just don't want to hit it too hard. Yeah. So here's the cap that holds the spacer on. There's our spacers distorted. We do order these, and if you cannot straighten it in a satisfactory condition, then replace it. We'll replace it. So here's your front bearing, back bearing. Here's the rest of the components. We usually, I take this, find a jig that is roughly, you know, the same size that it has a little flange on it that sticks up, and this little cap goes over that little ridge. So it's important for this spacer to be flat. So what I do is take it to start off, and I put it in one of these, and I go with the bearing part of the press, and gently through, and that pushes it down flat. So it's not perfectly flat, so what we do is reverse it a bit. Go. That's almost there. It still has a little bit of warp in it. Very important that it's very accurate. So we put it back in, find a hole that will catch nicely on that inner raised ridge part, and then what I do is take, again, the same tool. It's dulled down on the end so it doesn't gunge in any way. So what I do is just go around the perimeter of it and level it out. Voila, this is almost new condition. Again, if you can't get them back into good condition, replace them. In putting the bearing back on, it's important that there's two ways you can do it. You can put the bearing on, and the only way I can see with this, because well, actually this one works well. You just place the bearing on with your hand, and what I do is I like to just put it flat, and that way you look at it. Is it askew? Is it lined up properly? Because before you press it on, you want it to be as straight as possible. This type of press doesn't particularly work well with 472 bearings. You need a separate type of press for that, but it does work. So you put it in your
Is there a number or letter on that jig?
it can be 5, 6, or 7, or 4, 5, or 7 are the ones we have. So this one works okay for that. Now that it's on straight, but it may not be on all the way. So we find a jig that has a opening that is bigger than the spindle. You don't want it too big, like this one's bigger. You don't want it bigger because you want it to support as much of the bearing as you can. So what I do is put that on, and this is just to make sure that it's on all the way. So make sure it's lined up good and straight. Give it a little push. No reaction. That bearing was on all the way. So, but you have to make sure it's on all the way. If it's off by a thousandth of a millimeter, you're gonna have problems. It's gonna get hot. Again, this little cover has a little ridge inside it. So this side it doesn't, this side it does. And like I said, you can do it two ways. You can put it on the bearing, put the bearing on, or put the rear bearing on, then take your cover and work it over the bearing. It's a very snug fit, so.
Dylan, line 7, it's Julie. Dylan, line 7, it's Julie.
And you got to be careful. Sometimes in removing it, you distort the cover, the bearing cover that goes over it. So you got to make sure it goes on properly. Again, you'll have overheating problems if you don't. So that's fine. It slides on perfectly with just your fingers. So after that, you have just the front bearing. Front bearing is very simple. Again, put it on so that it looks as lined up as you can get it, using any jig that will support the spindle bearing and not be putting pressure on the button. So you put it on, line it up, there's your rebuild. To complete it, this type has a spring in it, and what that does, it goes on the bearing, and once it's in the canister, it holds it perfectly straight on that bearing, so there's no pressure on the actual balls in the bearing. If somehow it gets out of line or this spring is distorted, it may put pressure on the bearings that is a negative pressure. It's not good. Then you put the cap over it, the cap that you straightened, see, and it has a bit of spring on it, and that's the whole idea. This cap will go on, will hold this plate, and but it will hold it just so that there's enough pressure that there's a nice cushiony spring. Okay, and in putting this on, you want the top of this cap to be flush with the top of the spindle. Again, button side, make sure you're supporting it, and this is probably the best one. It has a small, very small hole, number one, that just the button will go through. And what I do is take a tool, and I like to use this tool because the more narrow tools, you get a better view. If you just put a broad tool, it's maybe not as accurate. I like to go with a narrow tool so you can really know see what you're doing. And the button is not, there will be no pressure on the button on the bottom. The whole spindle is supported. So all we want to do is come down, make sure the spindle is straight, and just give it a little push. You can see it's still not quite. Actually, I'm going to go with a slightly wider jig just to support a little further out, because it seemed to have a little rock on that one. Again, using the tool. Push it down so it is flush across. If you use this side and you push down a little too much, it'll put too much pressure on this spring. It's done. It'll overheat. It's just it's very sensitive. Has to be, in my view, when they come in, this is flush with the top of the spindle. So when you reassemble it, make sure it's flush with the top of the spindle. And once it's rebuilt, that's pretty much the whole deal here. I put just a dot of oil on the bearings. Give a little air to spread it around. And I don't put too much oil on it because I find once you reassemble it and start to run it, it gets quite hot. The bearings have to break in, and I think a lot of that has to do with the oil. If you put too much oil on, the oil is what causes it to get hot. It has to break down. It has to get to a certain thin viscosity, we'll call it, so that the heat starts to break down. I call it, you want to break the fever. Sometimes you can assemble them and they don't have any heat at all, but in a lot of cases, at first they're hot and you have to run them for 50 seconds, a minute, 2 minutes sometimes. And but if it isn't cooling down by then there's some pressure somewhere. With these things, if it gets hot, it means there's some pressure somewhere. Sometimes you may do a rebuild, it's still getting hot, and you realize that the heat is coming from a bearing in the shaft. Very important that you, I don't know if you can hear this, but this is a shaft that needs new bearings. You should hear no noises. It should be smooth. It shouldn't run on. See how that runs on? Shouldn't run on like that. It should run nice and smooth, no noises, but slow down much quicker than that. This shows that the grease is broken down in them. They are worn bearings. Again, if you check your shaft and it feels fine and your head is still getting hot, perhaps the bearing isn't, check to make sure the heat is not coming from there. And how you do that is you just put just the shaft into the handpiece all the way so that the gears are connecting. Make sure it's in all the way. You don't want any meshing of the gears. It could cause damage. But all the way in there, and I just hold it down, and you plug it onto the motor and run it, and it'll run. You'll see the gear spinning, high speeds. Run it at 20,000 at first. If it feels fine, run it at 40,000. Sometimes at lower speeds it won't heat up. At higher speeds it'll heat up. So yeah, you would just insert this all the way down, put it on your motor and run it. And if this gets hot, well, you know the heat is coming from the shaft bearings as well. In most cases, the rebuilds for these are very obvious. The bearings, you can feel them grinding. In a lot of cases, the bearings are broke to pieces. So, yeah, that's a lot of times it's pretty simple to diagnose these because the bearings are usually shot on them. Once they're done, you have that nice spring, the space in here. This is flush at the top. The bearings are pressed on all the way. Very important. Like I said, 1/1000th of a millimeter. If that bearing isn't pushed on, you're going to have overheating problems. These gears have to mesh exactly perfectly with these gears, or sometimes the heat will come from the gears mismeshing. So again, just another thing to look out for, and heating up is your sure telltale sign that something is not right. In most cases, they push back into the cartridge fairly easy. Happens a lot of cases is what I like to do is put a burr in the spindle. That way you can roll it. You can check it as you're putting it in and out, whatnot. It actually helps you line it up when you're putting it in. But you put it in, give it a little push with your hands. It snaps in there. All right, now the cartridge is in. It's rolling freely. It should be good to insert in the head, and if your shaft bearings are good, then you don't need to replace them. Simple matter of this back in the head, this screws back in there, make sure it's on good and tight. You don't want it to loosen up a month later, whatnot. So there you go, that's that.
You reassemble.
Yeah. Are we recording? Okay. One thing I should add is that when you push the bearing spindle assembly back into this canister, often it'll go in, and it will go in about 99% of the way, and you have to give it a little push, and you'll hear a little snap, a little pop where it pops into its final position. Check if it feels nice and fluid and smooth, no grinding, no funny noises, and that should be a perfectly good rebuild. So then this canister has a little bump on it, a little tab that goes into the top here. There's a little designated slot in there where this goes in. That keeps the canister from rotating. If it somehow rotates in the head, then these edges of this canister are going to go into gears. It's going to be not good. So it's some of these have this one has a kind of a it's all one piece with the canister. Some of them come with one little hole with a tiny little ball bearing in it. That's where you may lose that ball bearing, and a tip is that a lot of smaller bearings, like the little shaft bearings for NSK, a lot of small bearings have the same size ball bearing in them. Here is a ball bearing out of a bearing, extremely small, but compared to the spindle here, but the bearing that would drop in the hole of the other type, which are X95Ls, and in some cases, what's the other one?
Forza?
Yeah, the Forza F5s. Yep, and yeah, so some of them will come. Depends where you purchase them. Some of them will come with a ball bearing in. if that ball bearing is missing and you see a little hole there, it's important to find a ball bearing from a spent bearing or whatever, a stainless steel ball bearing, and believe it or not, has to be a fair bit smaller than this one. But there, if you do a lot of repairs, you'll have them somewhere, just in a, you know, if need be. The important thing is to try not to have that bearing pop out. If you, some cases, you get that spindle out, if you see it's going to pop out, push it out intentionally, keep it in a little container. Very important that you keep little parts in a container. You can't just leave them loose. You can't leave them in pans. As you can see, parts that are half the size of this, you lose them on the floor or whatnot, you're going to have problems. So that's a very important thing, is to make sure you put your parts in a container of some sort, just temporarily, while you do your repairs, so they don't go missing. Sometimes you'll catch them with your sleeve. Sometimes you'll put a tool down and it'll pinch them off. There's many ways that these parts can disappear if you're not careful. And yeah, in a lot of cases, very small parts, very difficult to find them. The tab on the top, the slot in the head, line up. Spindle has to push in all the way. If it doesn't go in all the way, where from the side you can't see the bearing, but you can see the button, then it's not all the way in. Roll it again. Sometimes the head itself is distorted. The spindle, the cartridge goes in tight. Then you roll it and it doesn't feel so good anymore. Well, that's the pressure caused by a distorted head. When triaging them, when analyzing them for repair, it's important to know that is this head in good shape? Is it, because sometimes it's really not clearly visible that there's a dent. It's misshaped. It's not an obvious dent. In other cases, there's an obvious dent. If that dent can be relieved from the inside and your cartridge go in effortlessly, then take that route. If it's gonna be too much to relieve the inside, it will affect the water spray. You're talking replacing the head shell as well. It's not worth it to do a rebuild on a cartridge and then have it back in a head shell that's distorted, and it's going to heat up. Again, the number one sign that something's not right is heating up. Once the cartridge is in, it feels great. You look for, it should be flush with the face. It should be no, it shouldn't be set in, it shouldn't be protruding in any way, the spindle that is. And once this looks perfect, so you should have no problem with your cap. What I do is we have to rebuild the shaft, but if this shaft was good, I would put the shaft on first, roll it, make sure it feels good, then put the cap on, and then tighten the cap. Once you get it almost tight, keep checking. As you tighten it, roll it. Is there added pressure each time you turn that cap? A tiny bit of a turn. Is it starting to slow the spindle down? That means that there something again is not right, and you are going to have overheating issues. This does not run very well because the shaft bearings are done on it. So take the shaft out, it runs just fine.